Hello everyone, today we're going over 4.3 logarithmic functions. Uh, in the beginning, anyone knows what is the meaning of logarithmic function with base A? What does that mean, logarithmic function with base A? Did you hear about this definition in high school?
I actually remember going over, but it was almost 3 years ago. I don't clearly remember.
It's fine. What about the other student? Anyone remember what's the meaning of logarithmic function? Or have you heard about this definition before, or this thing before? Okay, it's fine. So I will in the beginning define what is the meaning of logarithmic function. Logarithmic function with a base A. It is a function of the form logarithm, like this, log, like this, logarithm, logarithm x to the base A. This is equal what? Y. Yeah, correct, Aisha, the inverse of the exponential function. Very nice. Correct. Ashley, yeah, this is very nice. It's the inverse of the exponential function. This is correct. So logarithm x to the base A equal y. I can define it here by something I know it before. These things I know it before. It is A to the power y equal x. A to the power y equal A to the power y equal x. So first of all, we have to know this A is called the base. This A here, this A is called the base. For the exponential function, as we learned before, this is called the base, the A here. And also we have to know the Y here called the exponent. This is just a definition. We're going to use it during this section. Just you have to know this called exponent. When I said exponent, you have to know to remember the Y. This Y is called the exponent. Also, the exponent here is Y. So this Y here, this is my exponent for the exponential function. Exponent. So logarithm x to the base A equal y is the same as A, this A, this A to the power y equal x. Okay. By the way, so in the beginning, you have to know this side here, this side, it's called the logarithm form. This is the logarithm form. But this side here is called the exponential form. This is called the exponential form. Okay, so again, here, this is called the exponent, the logarithmic. The logarithmic form. And this side is called the exponent or the exponential form. So actually, there is a relationship between the logarithmic form and the exponential form. the logarithmic form and the exponential form, they have a relation. The relation look like this. Okay. Now, let me give you example.
Professor,
Yes, go ahead.
does that mean they're an exponential form, the same equation, when you turn into a log form, logarithm, it's the same thing?
Yes.
Okay.
Exactly. I will give you example. Like, for example, here, simple example. 6 to the power y. I mean, 6 to the power 2. What does that equal? 6 squared is 36. And a logarithm of, this is the x, the 36 to the exponent 6, to the base 6. This is equal to. Okay. So the logarithm, they give answer as the exponent. Look, the power of the 6 of the 6. Now let me give you example for the logarithm. So my first example is number 1. The logarithm of 1,000. So logarithm of 1,000. Hold on 1 second here. 1,000. This is 1,000. 1, 2, 3 to the base 10 equal. And the second one, the question is find the logarithm of 32 to the base 2. Okay, who do the first one? You have, I'm going to explain how you can think before you doing the first one, how you can think for something like this. Here to the power 10, by the way. To think, you have to set 10 to which power they give me 1,000. You have to ask yourself 10 to the which power, here number, they give 1,000. Eric said 10.
It's 3, no? 10 to the 3.
Let's check what Eric said. 10 to the power 10. 10 to the power 10 actually equal 10 times 10 times 10 times 2, 10 times. And these things will not give me 1,000. Okay, another student said 3. This is correct. 10 to the power 3 gave me 10 times 10 times 10. And this is actually 1,000. So the answer is 3 for the second one. 2 to which power? They give me 32.
It would be 5.
This is correct. This is equal 32. So if it's here, if it's the exponent, it's 5, I will get 2 to the power 5, 2 to the power 5, and this is equal 2 times 2 times 2 times 2 times 2, 5 times, and this is equal 32. So the exponent should be equal 5. Okay, any question? Okay, so here is 3, here is 5. So actually the logarithm asks for the exponent. 10 to which exponent or to which power they give me 1,000. 2 to which power or to which exponent they give me 32. So the answer is 5. Now we have some properties for the exponent. Of logarithm. So properties of logarithm. First property said the logarithm for 1 is equal, number 1, logarithm log to the 1 with any base a. A is a base. By the way, here I forgot important things. This a must be, this x here must be any number greater than 0 and is not equal any number greater than 0. The x here must be any number greater than 0, and this a must be greater than 0 and not equal 1. So logarithm the 1 for any base is always give me 0. Why? Because a to the power 0, a to the power 0 is always equal 1. Any number to the power 0 is always give me 1. Okay, number 2, the property number 2. The logarithm of a to the base a. This is always give me 1. Logarithm 5 to the base 5. Logarithm 6 to the base 6. Logarithm 7 to the base 7. Logarithm any number to the any number like 5 to 5, 6 to 6, 7 to 7. Always give me 1. Why? Because a to the power 1, a to the power 1 is always give me a. Give me this. And this is correct. Property number 3. Logarithm a to the power x with the base a. This is always equal x. Why? Because a to the power x, a to the power x, this a to the power x will give me inside ax, a to the power x. Understand? A to the power x, they give me the number inside. X equal a to this power, give me a to the power x. First of all, we should to know this is the green one, and this is my green one. And this the red one, a to the power x. Or if you want to explain this in different way, logarithm a to the power x with base a, this is equal, we can like make the x inside in front of the logarithm x, logarithm a to the power a. And logarithm a to the power a by using the second property equal what? 1. So actually is equal 1 times x, or x times 1, x times 1. And x times 1 is always equal x. So the answer is x. Any question? Do you have any question? Okay. Now property number 4 said a to the logarithm x to the base a is always equal x. A to the logarithm x to the base a always equal x. Okay, I'm going to give example to explain how we can use this properties. So the example as the following example. Number 1. Find the logarithm of 5 to the power 6 with base 5. Number 2. Find the logarithm of 1 to the base 6 or 7. Number 3. Find the logarithm 6 to the base 6. Okay, who will do the first one by using the properties above? Who will do the first one? Number 1.
Try.
Yes, go ahead.
So the first one is basically just rewrite the same thing equals 6.
6, exactly. Look, number 3, logarithm a to the power x to the base x to the base a is equal x. This x, the exponent for this thing inside the logarithm. So equals 6. Correct. Number 2. Who do the second one?
Professor, we can't see it properly. Can you please scroll it down a little bit?
Which one? The examples?
Yeah, no, scroll it down a
Just
little
the
bit.
two.
Okay.
I think it's there.
Now it's good.
Number, I can't see the value of log for number 2.
Number 2, it's logarithm 1 to the base 7.
Okay, base 7.
Yes, the base is 7. Logarithm 1 to the base 7. Someone said 0. And this is correct actually. Is 0 by using probability number 1. This is correct. Now who will do the third one?
So why is it 0?
By using probability number 1. Logarithm 1 to any base 7, 6, 8, 100, 20, 100. Doesn't matter.
Oh,
Logarithm the one,
anything log of 1 is 0.
yes, always 0.
Okay,
Log of 1, always 0 for any base.
okay.
This base must be greater than 0 and not equal 1. This a must be greater than 0 and does not equal 1.
What if it's 1 log and log has a subnumber of 1? 1 of
Sub
log of 1.
1 does not work.
1 does not work? Okay.
No, does not work. Okay, for the third one, who will do the third one? Yes is 1. Correct. Nice. By using property number 2. Logarithm a to the base a is always equal 1. Logarithm a to the base a always equal 1. Okay. Any question before we move to the next slide?
So number 2 is 0 because of property number 1, and number 1 is 6 because of property number 3
You said number 2 is 0 because what? Can you
of
repeat what you
property
said?
number 1, and number 1 is 6 because of property number 3.
Yes, correct. Yes, this is correct. Okay, now graphs of logarithm function. We're going to learn how to graph this logarithm function. So as usual, we learn how to graph the logarithm or any function by using the plotting point. I mean, for plotting point by using the table. Then we're going to learn how to graph any function by using the transformation. So graph the graph here of logarithm function. So I get a question, where did 3 come from? 3 come from number 2.
So for example number 1, right?
Yeah.
I know you used property number 3, but how did you get 6?
Okay, so look, log of a to the power x equal a. What's my a here? What is my a? What's the value for a?
5.
5. This 5 and 5. What is the value of x here?
5.
It's 6. Look, 5 to the power 6. This is x.
Oh, for the exponent is, yeah, the exponent is
Yes,
6.
6. So the answer for logarithm a to the power, like a to the power x with base a equal x. And here is the x is 6. Again, logarithm. So here logarithm a to the power x with base a. So my a is 5 and my x is 6, an example. And this is equal 6. Logarithm a to the power x, so it's equal log 5 to the power x 6 with base 5. and this is equal the same as x. My value of x is 6. That's why the answer here is 6.
Thank you.
No problem. Can you do an example for 4? For this one? Yes, go ahead. Here. So the example for 4 is like for example 5 logarithm 7 to the base a, or to the base 5. 5 raised to the power logarithm 7 to the base 5, and the answer is x. My x is 7. Yes, my x is 7. 5 to logarithm 7 to the base a to the base 5. So my a is 5 and my x is 7. So the answer is x. So the answer is 7. Yes, correct. You asking about this one? May I share? This is correct. Yes, this is correct. We can put the 6 in front, and logarithm 5 to the base 5 is 1, so we multiply 6 by 1. Correct. Okay, for the graphing, now I'm going to give example. So the example, you graph the function. The function is as in the table x, and here we have log x to the base 2. This is called to the base. So we have to pick a good number to plug it inside the logarithm, because actually we don't have to use the calculator inside during the exam. So we have to pick a numbers such that this number, when you plug it inside the logarithm, they will give me a value or answer. So I'm going to pick 2 to the minus 3 or to minus 2. And I'm going to pick, this is the suitable numbers. Why? Because if I plug these numbers inside the logarithm, I don't have to use the calculator to find the value. So 2 to the power minus 2. The second value is 2 to the minus 1. Third value is 2 to the power, for example, 0. And 2 to the power 1. And 2 to the power 2. Okay. Anyone can plug the first value inside the logarithm and give me the answer? When I plug the first value inside the function, the logarithm, what I will get?
1/4.
1/4. This is correct. Because the logarithm, no, this is, I will not get here. Let me check what you said. Logarithm 2 to the power minus 2 to the base 2. This is equal what?
Oh,
By using the
equals
bracket.
-2.
-2. So the answer is -2. But actually this is 1 to the power 4. This equal 1 to the power 4. Why? Because it's equal 1 to the 1 over 2 to the power 2, and 2 to the power 2 is 4. The negative means we have to move the number from numerator to the denominator. For the second one, logarithm of this number, what is the answer? Logarithm of 2 to the minus 1 of base 2 is -1. This is correct. And what is the value for this? 1 over what?
1/2.
2, correct. 1/2. Now 2 to the power 0, this is equal what here?
1.
1, always. Any number to the power 0 is always 1. Logarithm 2 to the power 0 of 2 equal
1.
0.
0.
Now the third one here, 2 to the power 1 is 2, 2 to the power 2 is 4. So 2 to the power 1 logarithm, the logarithm of 2 to the power 1 with base 2 is, yes, Mayasha, is 1. And the last one, logarithm of 2 to the power 2 with base 2 is 2. Correct. Now let's start graphing the function. So look what numbers we choose, because we don't have to use the calculator during the exam. So we choose this value, and this value help me to find the logarithm. So now let's graphing the function. This is the graph of the x. This is the x-axis. This is the y-axis. Okay. Now the first point is 1 and 0. This is the 1. Here is the 1 and 0. This is the 1 and 0. This is the first point. Second point is 2 and 1. Here is the 2, and this is my 1. So this is 2 and 1. Third point is 4 and 2. So 0, 1, 2, 3, 4. Here is 4. And 2 will be like around here. So again, 0, this 1, 2, 3, 4, 1, 2, 3, 4, and now now 1/2 and -1. 1/2 is here between the 0 and 1. This is the 1/2. 1/2 and what? And -1. Here's the -1. This is the -1. Here, by the way, is 1. This is, by the way, is 2. Okay. So here is -1. So this is the -1. So -1 and 1/2. Here is the point. Should be here. Okay. -1 and 1/2. And -2, I mean 1/4 and -2. 1/4 is between 0 and 1/2. So the point should be here. So the point, this is 1/4 between 0 and 1/2. This is 1/2. This is 1/4 and 2, -2, sorry. Here's the -2. So the point should be around here. So the graph of this function actually should be something like this. So this is the graph of the function, the logarithm x to the base 2. In the exam, are you going to give us the question like this example? Yes. So this is the graph by using the plotting point. Graph the function here by using the plotting points. Okay, this is the graph of the function. Look to this function. Always this function passing this point.
Professor,
This point. Yes, go ahead.
I was just waiting to ask this question. You see, how did you get logs of 2 and then 2 to the -2 again? It's the first one.
This one.
Yeah.
Okay, logarithm 2 to the -2 with base 2 is equal -2 by using the property here. Number 3. You see number 3?
Yeah.
Logarithm a to the base x with base a. What they give me? X, right?
Yeah.
Okay. So I plug by using this property, I can
how
solve
did you, yeah, so 2 over -2, how did you get that?
here. Logarithm 2 with to the power -2 with base 2. You see the 2 here? because this is my a. My a is 2 and 2.
No, I'm saying the x value, 2 to the negative 2. You
The
just chose?
the x value is -2. This is the x value. From here, I plug this value inside the function.
Oh, I'm saying you just came up with 2 and -2 in the x value.
Yes, exactly. I plug it inside the function. I put all this inside the function. Here is the function. I put all this inside the function. Okay.
Right.
Now, by using the property logarithm a to the base a, with the such that this a is raising to the power -2, so the answer is -2. By using the property logarithm
Got it. Got it.
a to the power x with a, this is equal x. Use this property to solve this question. Okay. Now we're going to learn how. By the way, this graph always passing the point 1, 0. Always. And you should to know there is a relationship between this function, by the graph of this function, and the graph of the exponential function. Both of them inverse to each other. So the inverse to each other, this is mean we have to reflect both of the function around the line y equal x. So this is here is my graph of for the exponential function. Here is the graph of, can you please explain the graph? Which graph? The previous one or this one? This one? Last one? How, like, what exactly do you need to explain? I mean, like how we apply the points? At 1 equals 0. Yeah, at 1, you see the 1 here? This is the x value, and this is the y value, y coordinate. We have order pair. The order pair has 1, 0. Here is the 1 and 0. The second point is 2, 1. Here is the 2, and there is the 1. Yeah, okay, you got it? Okay. Same things for the other points. Okay. Now, the graph of the function, of the exponential function, always passing the point 0, 1, like this. And it's close to the y-axis, but they will not touch the y-axis. This point is always 0, 1, 0, 1. And we should to know this function is reflecting around this line. This line actually is y equal x. This is y equal x. We reflect all the points in the black curve around this curve. So the point here will be reflected here. This point must be 1, 0. And everything here will be reflected like this. So this is the graph of the function. Okay, the red one is the logarithm function, logarithm x to the base a. This is equal y. And the black one is y equal a to the power x. Okay, so now we're going to learn, this is like the relationship between the logarithm and the exponential function. Both of them are inverse to each other. Okay, Now let's graphing by using the transformation. Example, graph each of the following by using the graph of logarithm of f of x equal. So I give you the original function here, f of x equal logarithm x to the base a. So my first graph, I should to know, I'm going to do this example here. So I have some space. F of x equal logarithm x to the base 2. This is my original function. Okay, so for the first one, yes, Brian. Okay, so for the first one, a part told me g of x equal minus logarithm of 2 to the power to the logarithm x to the base 2. Okay, how can I graph this function? So as I learned before, I have to write the original function f of x equal what? Log x to the base 2. I have to modify in this function to make it similar to the g of x. What I should to do here? What I should to do for this function to make it similar to the g of x?
Change the sign.
Subtract or multiply? Yes, multiply by -1. Correct. Multiply by -1 for both sides. So I will get minus f of x equal minus log x to the base 2. Now this function is the same as this, and this is equal g of x. So this is equal g of x. So I can rewrite this one. This is just a review from the previous sections. G of x equal minus f of x. So this is telling me to graph the function g of x, I should to graph the function f of x, then I have to reflect it around which axis? X-axis, Mir. Correct. So when the minus is outside the function, this is mean I have to multiply the function. I have to reflect the function around the x-axis. If it's the minus inside, so I will reflect it around the y-axis. Correct. Yes, Mir. Correct. So now let's start graphing the function. So to graph the function g of x, I have to graph the function f of x. Then I have to reflect it around the around the x-axis. So here is the original function f of x equal. Here's my graph of the f of x equal. This is the graph of f of x. This f of x must passing the point 1, 0, always, all the time. So this is the curve f of x. Now we have to graph the g of x, this f of x. So to graph the function g of x, we have to reflect this function around the x-axis because we have minus outside. So the graph will be, this point will be the same point. Now all this point will be reflected down. So here my mirror should be the x-axis. This is my mirror. Okay. So the point here should be the same point. And all this point will be reflected here. And for this point, also the same things will be reflected here, like this. Make it better than before. So the graph should be something like this. Okay, it's clear how to graph the function like this by using the transformation. Okay, part number 2. The question is graph the function h of x equal the logarithm of minus x to the base 2. Okay, how can I graph something like this? First of all, I have to write the original function is my function f of x equal the logarithm x to the base what? 2. I have to modify this function. What I should to do now to make it similar to the h of x?
Multiply x by negative.
Multiply the x by negative from inside, or in the other word, I can substitute minus x. So multiply this by negative or substitute the negative x inside the parentheses. So I get f of minus x equal a logarithm minus x to the base 2. Now this actually equal here, the black one, and this is equal h of x. So this is equal h of x. So I have to rewrite h of x as f of minus x. Can you back to the previous slide? Okay, but let me finish this first, then I'll go back. So the function here, h of x equal f of minus x. So this is telling me to graph the function h of x, I should to graph the function f of x. Then I have to reflect it around which axis? Mayasha, correct. Y-axis. Yes, safe. Around the y-axis, correct. So I'm going to graph the Cartesian plane, the x-axis and the y-axis. Here's my y-axis, and this is my x-axis. So the graph of the function, my original function is logarithm x. So logarithm x always passing the point 1, 0. So the graph should be something like this. Okay, this is the function f of x. This point again, just to remind you, is passing the point 1, 0 always. Now we have to put the mirror in the y-axis. So here is the y-axis. This is my mirror. It's in the y-axis. So we have to reflect all the points in this line. Now my first point should be here. 1, 0 should be this point. This point is 0, minus 1, 0. Now all these points must be reflected like this, and the points here must be reflected like this. So this is like the graph of the function h of x. This h of x. Okay, any question? Any question for this example? Okay, so now let's go to the common logarithmic. Can you explain this? I am a bit confused. For which one, Eric? This one, the red one? The second one, or A or B? This side. Okay, I have h of x equal logarithm minus x to the base 2. So the question telling me graph this function by using the transformation. So first of all, I need like original function. My original function is f of x equal logarithm of x to the base 2. And the graph of this function is look like this, the plotting point here, this one. Logarithm x to the base 2 is the graph like this. Or any base, the graph should be something like this. Now we have to put the f of x equal logarithm x to the base 2. Now we have to change something in this function to make it similar to this one, to the h of x. So if we plug the minus x inside the function f, so we get f of minus x equal logarithm minus x to the base 2. And this is similar to the black one here. This one is the same as this. And this is equal h of x, so equal h of x. Now we can rewrite these things as h of x equal f of minus x. This is telling me if you want to graph the function h of x, you have to graph the function f of x, then you have to reflect it around the y-axis because the minus is inside the parentheses. So first of all, you have to graph the black curve, the f of x, and this curve passing the point 1, 0. Then you have to reflect it around the y-axis. You have to put the mirror in the y-axis. So this point, it will be like minus 1 and 0. And all this point will be reflected here. And the same things here in the down will be reflected like this. Okay? No problem. Do you need the previous slide? Here's the previous one. Someone asked me for the previous slide. Okay. So now let's go to the common logarithm. Something new called common logarithm. What is the meaning of common logarithm? Is a logarithm with which base? Any idea? It's a logarithm to the base what? Any logarithm to the base 10 is called what? A common logarithm. So the base must be 10. So we denoted by something like this, logarithm log x to the base 10 is always equal a log x. So we can hide the base. We don't have to write the 10. Log x to the base 10 is always equal log x. So logarithm x to the base 10 equal log x without the base. Some example now. Find the log of 10. This is number 1. Number 2, find log of 100 equal. So who will do the first one? What is the answer for this one?
can try.
Yeah, go ahead.
So log 10. Wait, yeah, log 10 base. Do we have to put the base?
No, we don't have to put the base.
Mm,
But if
so
you want to rewrite it like to the base, log 10 to the base what?
10
Okay, what is that equal?
equals log 10.
Log 10 to the
Oh,
base 10 is
isn't
the
that equal to
same.
log 10?
No, I said before log a to the base a. What is that equal? By using the property?
1. Wait, was it 1?
1. Exactly.
Okay, so 1.
So the answer is 1. For the second one,
Can I do that one?
yes,
It would be log 100 to the
log
base 300.
100 to the base what?
100.
To the base 100?
I mean, sorry,
10, right?
10.
Yes.
Yeah, and then it would give you that's gonna equal 100.
10 to which power they give me 100?
Aren't you keeping the 100
I mean,
and the base is 10, so you're gonna like keep the 100
so what is the answer? Logarithm 100 to the base 10
on 10.
is 10? Is it 10? I mean, you have to ask yourself 10
I
with,
thought you're gonna keep the 100. That's what I thought, but like now I'm a bit confused on that.
no, it's fine. But for solving something like that, you have to set 10 to which power they give me 100. 10, this 10, to which power they give me 100.
10.
Is 10? 10 to the power 10,
Sorry, 10 to the second power.
exactly, is to the second power. So the answer is 2.
Yeah.
Yes, so the answer is 2. Correct. So
So
this
we
is about, yeah, go ahead.
Oh no, so in these cases we're just like doing regular exponents for these.
Yes,
Okay.
yes.
The other
But
one, that's when we keep the 100, like we would keep the exponent.
yes, by using the property for the first one, this property.
Thank you.
So you should to know here when you see log 10, you have to know the base is 10. This is the important things here. When you see something like this, log of 10, this is mean a log 10 to the base 10. You can use the property log a to the base a equal 1, or you can ask yourself 10 to which power they give me 10. 10 to the which power they give me 10. So if you raise this one to the power 1, they give me 10. So the answer is 1. Same things here. Log 100 to the base 10. 10 to which power they give me 100. So the answer is 2. So just they ask for another example. So my example here is 3, number 3. Number 3. Find the log of 10,000. Like this to the, without like this. Find the log of 10,000. What's the answer? What's the answer? Is it 4? Some students said 4, some students said 3. Okay, let's check.
Wait, no. I said 3. I thought it was 1,000. I didn't see it was 10,000.
No, it's 10,000. So log of 10,000, 1, 2, 3, to the base 10, you have to ask yourself 10 to which power they give me 10,000. Okay, so 10 to which power or to which exponent they give 10,000. 1, 2, 3, 4. So 10 to the power 4, correct, Eric? They will give 10,000 because 10 times 10 times 10 times 10, 4 times they will give 10,000. So the answer is 4. Okay? No, now we're going over the natural logarithm. Natural logarithm. So here we finish the common logarithm. It's a logarithm with base 10. Now the natural logarithm. Any idea about natural logarithm? What's the base of this logarithm? What is the base of this logarithm?
I want to say
So
5.
is the, did you, it's 5?
I'm
5?
guessing 4.
5 it's irregular numbers, so they will not be the natural logarithm. Here is cannot be 5, cannot be any number. Did you? It would be like a specific number. Did you know about the e?
Oh
Did
yeah,
you?
yeah.
Yeah. The e, it's the natural number. What is the value for e? What's the value for this e? It's a number. Yes, exactly. 2.7. Correct. 2.7. It's a number between 1 and 3 is 2.7. This e is 2.7. You should to know the logarithm of a to the base e. This is exactly equal ln, or it's equal ln of a. Again, logarithm of a to the base e is equal ln of a. We should to change the log function to ln of a. Or you can say the ln of x, I mean for this x, this is actually the same as, we know this is like the log of x to the base e, and this is the same as e to the y equal x, and suppose this is equal y, so e to the y equal x. So ln of x is e to the y equal x. If you want to write, okay, so if you want to write it again in different way, you can say y equal ln of x, and y equal ln of x is the same as e to the power y equal x. Okay. Anyone has a question? Anyone has a question? What's your question, Mayesha? Can you explain? So you should know the logarithm of a to the base e always equal ln a. Okay. If I ask you, this is easy, clear. This is clear here. But if I told you if y equal ln of a, how can I change the exponent to the logarithm to the exponential function? So I know the ln of a, what is that equal? The ln of a. If y equal ln of a, what is the ln of a equal? Log a to the base e. Okay? Log a to the base e. And like before, for the logarithm, e, by using the logarithm here in the beginning of this class, a to the power y equal x, a to the power y equal x, a to the power y equal x, changing the logarithm to the exponential form. Same things here. E to the power y equal what? A. E to the power y equal a. And this is the same as converting the ln to the e function. Any question? Here e, y. I'll make it good. So this is y here. E to the y equal a. This e to the y equal a. So we have some properties for the natural logarithm. Like before, properties of natural log. Natural log, it's a len function. The len function. The len. Here is logarithm of a is the same as len of a. So the first properties, first one, number one, said len of 1. Len of 1 always equal what? 0. Why? Because len of 1 is the same as log of 1 to the base what? E. And like before, I said log 1 to the any base always equal 0 by using the property before for logarithm. Where did you get y from? No, this is like I suppose y equal len of a. I suppose y equal len of a. This is from me, the y equal len of a. So how can I change the len of a to exponential function, Eric? So this is actually len of a logarithm a to the base e. So e to the power y equal a. E to the power y equal this a. Okay, Eric? Second one, we have to know the len of e is equal what? 1. How I know this? Because if I want to change the len function to the logarithm, this is equal log e to the base what? E. And like by using the property before, log a to the base a log 100 to the base 100 is 1 always. Now property number 3. Property number 3 said len of e to the power x. This is equal what? X. The same things like before. I changing the len to the logarithm. Log e to the power x with base e. And this is like exactly like the property for logarithm like before. This property, number 3. Log a to the power x with base a is equal x. Log e to the power x with base e is x. And the last property, number 4, e to the len of x is equal what? X. E to the len of x equal x. The same as the property before, changing the logarithm to the len to the logarithm. So it will be like e to the log what? X to the power e. This is as by using the property before is equal x. Property of the logarithm number 4. Okay, any question for this? Anyone know do you have any question for this properties? Okay, I'm going to give example. So the example is find the value for number 1 is len of e to the power x, e to the power 8. Len of e to the power 8.
Wait, sorry, can you go back for a second?
Yes, hold on. So the second one is len 1 over e squared. So here's len of e to the power 8. The second one is 1 over e to the power 2. Here you go.
Actually, we cannot say the last one.
Oh, you cannot see the last one, so I'm going to write it here. Number 4. Can you see here?
Yes, yeah. Actually, wait,
Okay.
I see it now. Oh, you just have to expand your screen to see it.
So,
I still
okay,
cannot see it. I'm sorry.
here's good now. Can you see it or not?
Yes, yes.
Okay.
Thank you.
No problem. So for this example, who will do the first one?
I'll do it.
Okay, go ahead.
So the answer is 8.
Exactly, it's 8. Which property did you use?
The third one.
Third one, ln of e to the power x equal x. So my x here is 8. Ln of e to the power 8 is 8. So the answer is 8. For the second one, who will do the second one? This is actually equal ln of what? Yes, Eric, correct. This is equal ln of e to the power minus 2. When I move anything from numerator to the denominator, we have to change the exponent from positive to negative or from negative to positive. We have to change the sign for the exponent. If it's positive, must be negative. If it's negative, we have to change it to the positive. So here we get ln of e to the power minus 2. And by using the same property like before, this is equal what? Minus 2. So the answer is minus 2. Okay? Any question? Okay, this is what you should know about this section. By this example, we finish this section. So now let's go to a new chapter, 5.1. 5.1, angle measure. We're going over the trigonometry now. So 5.1, angle measure. Okay. So we have some definition here. We should I will go over these definitions. Just we're going to use it during this section a lot. The angle measure, we have to know what is the mean of angle. What is the mean of angle? Do you know anyone knows what is the mean of angle or has any idea about angle? Okay, the angle, if I have two rays like R1 and R2, and the both of the rays are intersect at the point, this point called the vertex O. So we can make angle, and the angle be look like this. So I'm going to define the angle as, so two rays. The first one is R1, the second one is R2. R intersect at a point. This point is called the vertex, the original, or the called vertex. Like it's a point such that this point is the intersection between these two rays. So I'm going to graph like easy and sample one. So suppose my first ray look like this. This is the first one. This is R1. And I have another one. This is my second one. Both of them intersect at a point. The point is this. The point is this point. So the point should be here, this point. This point here is called the vertex. Vertex. This point is called a vertex. And this is my R1, the first ray. This is R1. This is R2. Both of them are intersect at this point. This called the angle. This is the angle. The angle here, I can name it as, if I have here, for example, point is A, and this point is O, and this point here is B, for example, I can call this angle as something like this, angle of AOB, AOB, like this. So this is the angle. I define the angle by using two rays intersect at a point. This point is O. Okay, this is the first things in this section you have to know. Also, you should to know what is the initial side, the definition or the meaning of initial side and terminal side. So here are some notes. This notes will help you during this section. So the first one, if I start measure the angle from R1 to R2. So I mean, if I want to start measure the angle from R1, this is my R1, this is my R2. So here I can call R1 as my initial side, and R2 as terminal side. This is very important here. R1 is my initial side, R2 is my terminal side. So for the previous graph here in the above, this R1 is called my initial side and R2 called my terminal side. Why? Because I start measuring the angle from R1 to R2. So here I'm going to call this one as my initial side and R2 my terminal side. My initial side, my terminal side. Also, I should to know when this angle will be positive. So note number two. This note will help you a lot during this section and the next sections also. The angle will be positive if the rotation for the measuring the angle counterclockwise. So we know how is the clockwise, how is the rotation for the clock. So counterclockwise is the opposite of the clock. Counterclockwise is the opposite of the clock. So I know how is the clock, the watching clock. It's moving like this. So here is my y-axis and this is my x-axis. So the clock moving from here like this. You look into the clock, it's moving like this. But counterclockwise will be in the opposite side, like this. This is counterclockwise. Here, counterclockwise. By the opposite side. The green one is clockwise, but the red one is counterclockwise. Counterclockwise. Is it clear? Do you know now what is the meaning of clockwise and counterclockwise? So the angle will be positive. This is very important here. The angle should be positive if the rotation for the measuring the angle counterclockwise. Counterclockwise. It's anti? No, I never heard about this one. If it's clockwise, the angle will be negative. So here, for example, here is counterclockwise. Why? Because my initial side is this, my terminal side is this, and the angle is AOB, and the measure is counterclockwise. So this angle must be positive. Must be positive, I mean, for example, positive 30, positive 45, positive 60 degree. Example like this. But if it's clockwise, the angle will be negative 30 degree, negative 45 degree, negative 60 degree, stuff like this. So here is, in this example here, this is counterclockwise. So the angle will be positive. Okay. So I'm going to give you more examples to show you about this one. So if
Professor, sorry,
yes,
can you please go back? You
yes.
see, which one is clockwise and which one is counterclockwise for the red and green?
The red
Can you
one
please say it
is,
again?
yeah, the red one is counterclockwise, but the green is clockwise. The green one is clockwise because look to the watch. The clockwise look like this. This is the moving way for clockwise. The red one is the counterclockwise. The red one is the counterclockwise.
Okay, thank you.
Okay, no problem. So here the counterclockwise, I will put the red color box to show you. I use the red to graph the counterclockwise. This is the red. This is mean I use the red to graph the function. So I'm going to remove the green also. This is means counterclockwise, like this. Counterclockwise is positive. Yes, Mayasha, this is correct. Now, if, for example, some notes, if I have R1 goes to R2, so this is my R1 goes to R2, like this. R1 goes to R2. So the angle here, this is R1 goes to R2. So my graph for this, suppose it would be something like this. Here's my R1. This is my R1. And this is my R2. And the vertex point is here. This is the vertex point. By the way, I have to give the label for the rays. So the ray here is R1. This one is R2. And from R1 to R2, the question tell me from R1, the angle is from R1 to R2. So from R1 to R2 is supposed to be like this. This is R1 to R2. This is the angle. Here, this point, I have to take a point in the R1 to name the angle is A. Suppose this point is A. Suppose this point is B. Suppose this point here, the intersection is O. So the angle is AOB. AOB. So what's my initial side here? What is my initial side?
A.
Is R? Which R? R1 or R2?
R1.
R1, exactly. So R1 is my initial side. Why? Because I start from R1 going to R2. So R1 is my initial side. And what's about R2? Is,
Terminal.
yes, my terminal side. Because I end it by R2. So I start from R1 and I stop until R2. So R2 called the terminal side, R1 is called the initial side. Also, what is how is the rotation for this angle? Is it clockwise or counterclockwise? What is the rotation for this angle? Is it clockwise? This is correct. And what's the sign for this angle? Is it positive or negative? Correct. It's negative. So here I can say it's clockwise, and so it is negative angle. So because it's clockwise, so the angle here should be negative. So I start all this answering by here for the first step. R1 goes to R2. So I'm looking for R1, I'm looking for R2. This is my R2. So here, R1 and R2. This is R2, here R2. Start looking for R1. This is R2. I look at how is the direction, rotation, I mean. The rotation is starting from R1, goes to the R2. So the angle will be like this. The angle starting from R1 goes to R2. The angle opening like this. This is mean when the angle start from R1 to R2 and the angle look like this, it's a clockwise, and the angle here must be negative, Now, how we can convert between degree and radian? So we have two kind of angles. We have degree and we have radian. We have degree and also we have in the same times radian. So convert from radian to degree and from degree to radian. So here convert. We have like small formula. I will show you what is the formula. Convert between degree and radian. Convert from degree to the radian. So we should to know the degree. If I have, like, you should to know the 180 degree is equal by radian. So here we have to know 180 degree. This is equal by radian. So to convert from degree going to radian, you have to multiply the degree by over 180. You have to multiply this here, the degree, by over 180. And to convert from radian to degree, So here we have the radian to degree. What we should to do? Anyone has idea? You have to multiply by what? We have to multiply. It will be multiplication again.
Are you gonna flip it?
What
Are
we
you
have?
gonna like 180 over?
Flip
like
it.
180
Exactly. Correct. So we have to multiply by the flip of this 180 over pi. Multiply what? Multiply the radian by this, I will get degree. Multiply the degree by this, I will get radian. Let's take example. The example is express the 60 degree in radian. And number 2, this is the first one. Number 1, express the 60 degree in radian. Second one, yes, I will go back. 1 second. Express the pi over 6 in degree. So here, express the pi over 6. Here, the pi over 6 in degree. Here you go. Okay. Okay, so who will do the first one? Changing from degree to radian. Radian divided by 2 divided by. So the first one, for the first one here, to change from express the 60 in radian, so from degree to radian, what we should to do? Multiply by
radian.
Radian over 100. Yes, correct. So here I will get 60 times radian by over 180. Now I can simplify this 60 with 180. So the 60 is 1. Here I get 3. So I will get pi over 3. And pi over 3 radian. This is the answer for the first one. Who will do the second one? From radian to degree.
I'll do it.
Yes, go ahead.
Okay, so radian over 6 times 180 over radian sine.
Exactly. Nice. So now I can cancel the pi with the pi.
Yeah.
This cancel out. I will get 100 over what?
6.
6. And this is equal what?
30.
30.
Yeah.
So 30 degree. It has a circle, small circle like this. This means the degree. No, here, Mayasha, do we have to put the pi number 3.1414? No, this is not correct. You can't put 100 pi as 3.14. This is not correct. The pi here is 180. This is the meridian. Now the angle in the standard position. So the angle in the standard position. I mean for this, the angle in standard position, the initial side must be in the x-axis, the positive x-axis, and also at the same time the vertex of the angle must be in the origin 0, 0.0, 0, I mean, for this again, the angle in the standard position, this is mean the angle such that the initial side it's in the positive x-axis and the vertex is in the origin 0, 0. This angle is called angle in the standard position. Again, so if the initial side is the positive x-axis, this is the first point. The initial side is the positive x-axis. And number 2, the vertex. The vertex must be the origin point. The vertex is at the origin. I mean, at the origin is 0, 0. I will explain this by using graphs. So the graph of this, for the first one, this angle, it's in the standard position. Why? Look. First of all, we have to graph, I should to graph my x and y axis. Here is my x-axis. And this is my y-axis. For the second one is here. This is my x-axis, and this is my y-axis. And also, again, this is my x-axis, y-axis, and the same things here, x-axis and y-axis. For the first one, suppose my initial, it must be the initial side. The initial side must be in the x-axis, like this, the positive x-axis. And also, the vertex is look like this, the angle look like this. So here is the angle. This is the angle. This is my angle. So it's here, the initial side is the positive x-axis. Look, this is my positive x-axis. And the vertex is the 0, 0. Here is the 0. This is the 0, 0, the vertex. This is the vertex, and this is my initial side. Here is the vertex. This is my initial side. This is my terminal side. And this is my angle. For the second one, suppose my initial side, always my initial side, it's in the positive x-axis. And my terminal side is this. Okay, so this is in the angle in the standard position. Why? Because the initial side is in the positive x-axis and my vertex is the 0, 0. Here is the 0, 0, the vertex, and this is my initial side. Initial side. This is the vertex here. And this is my terminal side. Okay, for the third one, I can graph my angle look like this. So this is my initial side. This is my initial side. And I will turn around the x-axis like this, and before I turn around, so this is my terminal side, and the angle is like this. The angle starting from here, go around, then go back here. So again, starting from this point, the initial side, turn around, then go back here. So this is my terminal side. Initial side, terminal side. And here is the vertex. So if I turn around 2 times and this is where I stop, this is called my terminal side. Where I start is always called my initial side. For the last one, so for the last one, here's my initial side, always the positive x-axis, and the terminal side, it's anything like this. Suppose it's this. So the angle, it's like this. Starting from this point, go around, stop up here, then go around, stop up to here. So this line is called my my terminal side, and my initial side is the positive x-axis. Here is the positive x-axis, my initial side. Here's my terminal side. And this is my vertex. Vertex. Okay, any question? Any question for this? Okay, have a good day, everyone, and I will see you Thursday.
Wait, I have a question.
Yeah, what's your question?
Do we have school on Thursday?
Thursday.
Isn't it Thanksgiving?